The actual TV cabinet itself also greatly influenced the overall scale and design of the cabinet itself. Now, most arcade machines don't use TV sets, they use dedicated monitors, and if you were to open up the cabinet, you'd see that the monitor itself is completely bare with the electronics visible, and a high risk of being electrocuted if you don't know what you're doing. I didn't want to do that because I don't know what I'm doing, and I thought I don't want to remove the tube and all the electronics from the TV cabinet, the big plastic box that it came in. I wanted some means by which I could accommodate the entire TV set, partly for safety, but also so that I could reuse the TV in some other projects, say if it didn't work, or if I managed to get hold of, say, a Sony broadcast monitor in the future, that I would replace it with. So my plan was to accommodate the TV on some sort of tray that would slide in and out of the cabinet. And by sliding it out, it would also provide easy access to wiring the controls later. That is another thing that you'll need to consider. But the actual plastic box itself was curved and quite hard to accommodate, so building that tray was more complicated than it arguably had to be. And again, I had to make sure that it would fit inside the cabinet plan itself. In terms of the actual plans for the cabinet itself, I went to a website called jacobud.com. I've put a link to that below. And that again is run by an enthusiast or enthusiasts who have recreated plans for a selection of vintage arcade machines, including fortuitously Gallagher. Well, not fortuitously, because it is one of the most popular designs, that classic 1981 Midway cabinet. And for me, I wasn't so much bothered about the control panel or any of the front panels because I was going to worry about those myself. The parts that I was most worried about were the side panels and that actual shape. Now, it would be easy to just cut it out and make the side panels straight away, but it needed to fit the actual TV cabinet. So the first thing I did was to actually make a scale outline drawing of my TV set and then position it using Photoshop or any other software on top of the outline of the cabinet. And then I would scale the actual cabinet up and down and then move the TV around, rotate it, and actually see how it would fit inside. And what you'll discover is if you are trying to accommodate tube monitor, they're as deep as they are wide, and again even more so if you're keeping them inside their plastic case as I was. It's not going to fit in very, very easily, and I needed to actually make it a bit deeper at the back in order to accommodate my TV set without it sticking out. But it's also a very important lesson because you can see how the whole thing is going to fit together, and it will allow you to look at it and think, well, I'm going to need supports for my screen here, but then if they're there, how am I going to get in order to wire it? Because you're probably going to be wiring it up after the entire cabinet is assembled. And of course, at some point in the future, you are going to need to replace one of the buttons or the wiring may come loose, so you are going to need to think about access. But again, I started with those original Jacobud plans for a Midway 1981 cabinet, resized them, stretched them around a little bit, and then I would have an idea of exactly how big this thing was going to be. And as luck would have it, scaled down to fit my TV set, the side cabinet pieces itself worked out at about 1.2 meters. And that's important for me where I live because most wooden sheets are supplied in a 1.2 by 2.4 meter shape. As such, I realised that I could actually fit both side panels and all of the front panels along with a bunch of bracing panels onto one single sheet, which I really liked, not just for efficiency, but to save a bit of money too. Now, the original arcade machines used 18mm thick paneling approximately, often used MDF, but I wanted to scale this down authentically, so my 3/4 scale then resulted in paneling that was 12mm thick, and that's too thin for MDF, and I don't like working with MDF anyway, so I chose to do it with plywood. Now, most people who are attempting their own DIY arcade cabinet would at this point retreat to their dedicated workshop with full-size drawings that they printed out or drawn by hand, and they would stick it onto the wood panel and then go around it with a jigsaw or whatever other tools that they have. But I have neither the workshop nor the skill to do that. I mean, I can put up shelves, I do have a jigsaw, but I wanted this thing to look really smart and very, very crisp, and I just don't have the tools or the skill or the place in which to do it. But then it occurred to me that I could get someone else to cut it out for me. In fact, to get a machine to cut it out for me. So I approached a local CNC firm. Now, CNC is basically a term that's used for giant computer-controlled cutting machines. They use various routing or drill bits to cut out exactly the shape that you want. You can use them to also put in the screw holes in advance or any other cutouts that you need. And all you do is supply them a drawing to drive the machine, and it basically prints it out by cutting them out from the panel. I went to Cutting Edge CNC in Lewes, which is a nearby town to Brighton, and they quoted me £117.60 for the sheet of plywood, that was 12mm birch plywood, and all of the cuts, which to me seemed like a bit of a bargain. The only thing is that their machines require a file that's generated in AutoCAD to drive them properly, and I don't have AutoCAD, and I've never really been able to get my head around CAD, and in fact my drawings were done by hand in a notepad, but they were pretty simple. So it occurred to me that it wouldn't take somebody who was experienced in AutoCAD very long to do that. And luckily my friend Ben, who helps me with some of my photography videos, he's an AutoCAD expert. So over lunch and coffee and cake one day, he turned all of my hand drawings into properly dimensioned AutoCAD files, and I've saved you the trouble of doing this yourself, and I've provided links to those files below so that you can do it, or you can at least see the plans that I used to create it. Now, once again, I found that I could fit both side panels and all of the required front panels, the control panel, the top, everything that I needed into this single sheet. And anything that was left, I just basically cut out into additional sheets that I would be using for internal bracing and also to support the TV set. Now, sadly, I didn't get to see or film the machine cutting out the pieces in practice, but this is the machine which did the job. And here are the finished pieces all stacked up. And as you can see, they're absolutely perfect as they would. It's been cut out by a computer, and it's provided a smoothness to those curves and an absolute perfect symmetry that I would never, ever have been able to achieve if I'd attempted to cut these out myself. So that was money well spent in my book. Next, I needed to prepare the panels for the T-molding, and that is the strips of plastic that run around the edges and give it a really smooth finish. It's something that you notice on all arcade machines. Now, they don't just go around the side panels. I've seen a lot of people employ them to join together or hide the seams or a multitude of other evils on the horizontal sections of the build. I didn't want to do that. I was hoping to actually not have many gaps or cracks or anything else because the parts had been cut out by computer, so they should fit together pretty much perfectly. So I planned to only fit them to the outer edges of the side panel, but they were going to go all the way around. Now, before I embarked on this project, I had no idea how this molding effect was actually achieved. I assumed it was just a strip of plastic that was, slightly rounded and you glued it over the edge. But in fact, the thing that keeps it in place is a hidden bar which comes down from that surface, and that's where it gets the letter T from, for T-molding. So what you need to do is cut a groove in the side of the panels that is the correct width and the correct depth. Now you need a special tool to do this. You need a router with a bit that is the correct size. I own neither the router or the bit, so I bought the bit for £12.99 and I hired the services of a local carpenter friend who did a bunch of work for me and charged me £50 for it. And he did a brilliant job. So here he is. Actually cutting that groove around those side panels. And he also suggested that the plywood itself should be sanded, and this wasn't something that I'd thought about. I thought, well, it's going to be smooth enough, right? But after he'd polished just one panel, it almost felt like glass compared to, a traditional rough wooden surface. So I was completely sold. So sanding the panels is definitely worth doing. And it will also save you money on painting later, because the paint went on and looked very good in just one or two coats, whereas the unsanded surfaces generally soaked it in and took a lot more paint to cover it and didn't look as good afterwards either. So I would recommend sanding. So he sorted that all out for me. Now, I'd routed out those grooves for the side panels because it was easier to do it when they were just single sheets than before the actual cabinet was assembled. But I'm not going to stick on the actual T-molding until later on in the video. And now it's time to finally assemble the cabinet itself. And I assume this was going to go along similar lines to some basic shelving projects that I'd built before for hi-fis or for books, where I'd drill holes through the actual side panels and then screw into softwood battens that would support the shelves. And because that's a similar kind of structure to what I was building here, I assume that's what I was going to do. And if you are going to do it that way, remember, if you are doing a CNC computer cutout process, that machine can drill the holes for you in exactly the positions that you want them. But I didn't choose to drill holes, and that's because after doing some research into arcade cabinets, I realized there were no screw holes, not even ones that were very carefully covered up and painted over. It turns out that most arcade machines are actually glued together. This was something I was a bit skeptical about first because I'd never tried gluing something so big and heavy together before. But of course, the right glue can be very, very strong, especially if you do it properly and you compress it and you allow it to dry. So that's what I did. I bought some decent wood glue and I built the cabinet one section at a time. Again, I didn't have a big work area that I could devote to this. And I also only had a limited number of clamps and things to actually hold it together. So I built each middle shelving section by themselves. I would take the panel, I would get my wooden battens and I would glue them on. And I'd press it down with a load of heavy books to keep it in place. And I'd typically have room to do maybe a couple of those at a time. Leave it to dry overnight, then start work on the next bit. And gradually, I built up all of those parts. Now, the most important part of this assembly process was the control panel, because I wanted it to look really crisp, really sharp. It's the thing that you are going to be concentrating on the most as you play the game, arguably, and it's the thing that you notice first of all when you walk into a room is that front section. So I wanted it to look very nice, and one of the bigger challenges was to work out how to join two of those panels together, because of course you have the top panel where the buttons and the joystick are, and typically this would be angled to be ergonomically easier to play, and then you would have another piece that would go in literally with a 90-degree angle between them. And how they join is something that differs on a lot of different cabinets. On some, there's just a 90-degree join, which is sharp or sanded off. Some of them get around it by, again, just getting rid of T-molding or plastic and just sticking it over the top. But I always thought they looked very messy. I've seen some people who generate a curve using a sheet of metal that may then continue onto the top of the control panel itself. And I thought about this for ages. And then while I was in an actual woodworking shop, I noticed quadrants, which are sections, quarter sections of a circular piece of an actual cylinder. And these are typically used to sit on top of skirting boards or picture rails, or they're used for decoration in the home. But they're also perfect for achieving really nice curves in a build like this. The only question was, what kind of radius should I go for? The most obvious radius would be one that matched the actual thickness of the panels, so that would be 12mm. But I also bought some that were a little bit smaller and also a little bit bigger, and tried them all out. These pieces could be adjusted at this point on the final build. It wasn't critical whether one was a little bit further out or a little bit higher than the other. So I experimented with the different radiuses, and of course found in the end that the best one was the one that matched the actual thickness of the panel itself. So I went for a 12mm radius for the quadrant, and then glued it all together very, very carefully so that you had a perfectly smooth surface for that control panel section, because it's where your wrists are going to rest, especially on this scaled down version where your palm is actually going to probably go over that curve. So it's going to have to be smooth, it's going to have to be comfortable, and it's got to look good. It is going to be covered by a vinyl sticker for the artwork later on, but of course if there are any lumps or bumps, they're going to show through, so it had to look good. Once I'd assembled all of those sections that would go across the middle of the cabinet, it was time to actually glue them onto one of the side panels. So I got my AutoCAD drawings and basically drew them out where those parts would actually appear and be fixed onto that side panel. I drew it on the inside of both of them in pencil, very, very carefully with rulers, measuring it all out exactly. And this is again why it's really nice to have a proper AutoCAD technical drawing to work from, because it's dimensioned perfectly. You know exactly what those dimensions are and how it's going to fit together. And then it's just a case of carefully gluing each of those sections on the side panel, which is now flat on the ground. And if everything is square, if all of your battens are square and all of your cuts are straight, then it should all pretty much line up without any gaps at the top. If there are some gaps, you might want to put some tape on or use some elastic bands or string to just pull them together a little bit. But I was pleased to see that it did actually all line up very, very effectively. And that's because a computer cut it out and I employed a professional carpenter to cut out some other sections for me. So I was not involved in any of the cutting process, and that's why it fitted together perfectly. One of the most stressful parts was then gluing the other side on top of that. First of all, you'd rest it on top without any glue, have a look underneath, and make sure that each of those side panels is perfectly matching up with the drawing marks that you made from that original AutoCAD design. And again, because most of the wood was perfectly square or squarely cut, it did fit together very well. I did need to tape a couple of bits just to pull them in, drag them one way or another, but eventually it was all lined up correctly. I glued it, weighed it down with a ton of books and just walked away because it was too stressful to look at it any longer. Just a brief note on the design of that cabinet again. I should note that even though I glued it all together, I did screw in two particularly thicker battens that I used at the bottom of the cabinet because they would be supporting the entire weight of the machine. To be honest, now after the event, I think glue would have been perfectly adequate, but I just wanted to put a screw in there to make myself feel better. And it's at the bottom of the cabinet, you can barely see it. I should also add that on that original design, while I did have some spare wood to make some additional bracing panels, much of the rear of the cabinet is actually wide open. Now, I was confident that there was enough wood and enough bracing to hold it steady and hold it straight, but most of the rear was open. And at this point, I wasn't entirely sure what my plan was for that. Maybe in the future to buy another sheet of wood and cut it and fit a back panel. But at the moment, I just left it open because that would provide full access to putting in the controls, wiring them up, and also sliding in the TV set and providing access should anything go wrong or need changing. And you know what? With the actual cabinet placed against a wall, you don't even notice no rear panels. So it's open, it's providing airflow, and it's absolutely fine. And I think I'm going to leave it that way. After the glue had dried the next day, it was time to start painting it. And I wanted, again, a nice smooth finish, so I used a small roller and a tin of black paint, which both came to about £10, and just gradually rolled it on. I was also very careful about how I painted the front section of those panels with the routed groove for the T-moulding. I did not want paint to get inside that groove and make it harder to put the T-moulding inside. I've read some horror stories about people who've routed out a groove, painted it, accidentally filled the groove with enough paint that they couldn't get the T-moulding in, and then they had to route it again. I did not want to go through that process, so I was quite careful, and thankfully the roller managed to paint those edges without putting any paint really inside the groove, so that was pretty quick and easy to do. One of the best things I did in this build was to fit wheels to the bottom of the cabinet. Now, I wondered about this for a while. Should the cabinet just sit directly on the floor with the panels touching the flooring directly? Should there be kind of rubber feet on it, or should there be wheels so you can move it around? My reluctance to using wheels was that I thought the cabinet might wobble while you were playing it, but in the end, the wheels I chose worked really, really well. They're 50mm caster wheels. I used a company called GBL. They cost me £12.99 for a set of 4. And these are lockable ones, so you can actually push down with your foot on a lock, and that keeps them in place. And with all 4 wheels locked, it's pretty sturdy and you can play quite vigorously and it doesn't shake around too much. But the most important thing is with them unlocked, you can just wheel it smoothly around your room. And this is also great when you're configuring it, because you will find you are constantly looking at the front, turning it around, rewiring it, turning it back again, turning it back and forth. And without the wheels, that would be really hard. So they worked out really, really well. And they're the rubberized ones, so they don't leave any marks and they turn smoothly and silently. So wheels are definitely the future. Okay, now it's time to fit that T-moulding. And because I was just using it on the side panels, I again went back to my AutoCAD drawings and I asked Ben to calculate the circumference of them, because that is a number that it can come up with straight away. Although you could always use a piece of string, couldn't you? And I calculated that I'd need about 25 meters in total. And that cost me £20.10 from Arcade World, which has a bunch of different T-moulding colours and widths available. Of course, if you're building a 1-to-1 original size, you're probably going for 18mm. but I went for 12mm to match the actual panels that I was using. But what colour? Now, I assumed it would be black to match the colour of the cabinet, but again, looking at some old pictures of some original Gallagher cabinets, I saw that some people had used green, because there's a lot of green in the artwork, and you know, it looked really nice in green, and I was very, very tempted, but I saw so many pictures of it in just plain black that I decided to be traditional, be a bit boring, and just go for black coloured T-moulding. So I ordered it and found that when it arrived, it slotted very nicely into the grooves that had been cut. Now, the idea with T-moulding is if you look at it from the side and you've got that T coming down, that will go along the straight edges very well. But when you go around a corner, you just need to cut out little triangular notches so that the actual surface can curl around. And that can be done very easily with a craft knife as you put it on. What you will probably need to do is use a bit of glue. I used hot glue to hold it in place. But because the actual T-moulding nib part and the groove didn't quite fit, some people find it's a bit tight and they need to hammer it in. In the case of mine, it was actually a little bit loose, so I ended up having to mostly glue the entire path as it went around. But it went in pretty easily, and it just absolutely transforms the look of this cabinet. Suddenly what was just a wooden project now looks like the machine from your dreams, how you remember it. So I'm really pleased with the way the T-moulding worked out.